We are talking about parallel lines and proportional parts, and we want to use proportional parts within triangles. So here in example 11, we have an angle bisector, and it's angle bisector because we have the two angles marked there, where that angle is congruent to that angle. So we have the angle bisector, and so we can set up our proportion, and we'll just put the proportion in like that. Now the thing that's missing is we're missing this side right here. We have all the other values. So we can set up the left side, which is going to be, and actually I'm going to kind of switch this. No, we'll leave it just like this, sorry. 6/3, and that is going to be equal to, and now we got to decide what the right side is going to look like, the right side of our proportion. So we have 2 plus x, or x plus 2, and we know that this distance is 3, so we got to figure out what that value is left. So we're going to say x plus 2 minus 3, and so when we do that, we leave the x alone, so that just becomes x, and then 2 minus 3 is -1. So this value right here is x minus 1. So we can set up the right side of our proportion, which is going to be 8 over x minus 1. Now we can do our means and extremes, and we have 8 times 3, and that is going to be equal to 6 times x minus 1. Now on the left side, we can multiply those two together, and 8 times 3 is 24. So we get 24 there. And then on the right side, we can distribute the 6, so we get 6 times x, and 6 times -1, which is -6. Then we can add 6 to both sides. The 6's cancel, and on the right side, we're left with 6x. On the left side of the equal sign, we are left with 30. And then we can divide both sides by 6, and we get 5 is equal to x. Then for example 12, this one is going to be the mid-segment theorem. And the mid-segment theorem says that if we have two things that are congruent, so right here we have two congruent lines. So right there we know that V is the middle of FE. Here we have two more congruent signs, but this time they have 2 marks each, so we know that W is between F and G. So the only things that we really care about are the mid segment here and the side that's parallel to that. And that's parallel right there to this line right here, because WV is the mid segment of that triangle. And now we can say which one is bigger, is which one looks longer, is WV the longer one or the shorter one? And we can see that WV is the shorter one. So we can say x plus 23 is equal to, I guess we'll change that to equal to 1/2, because that's never going to change, 1/2 of 35 plus x. Now, we could distribute the 1/2 in, but 35 is odd, and then that would leave us with a 1/2 x. So we could just get rid of this 1/2 altogether. And the way that we do that is we multiply both sides by 2. So I'm going to multiply this side by 2 because this 2 is going to cancel this 2. And I'm going to multiply the left side by 2. And I have to make sure I distribute it to all those parts. So 2 times x is 2x, and 2 times 23 is 46, and that is going to be equal to 35 plus x. Now, I'd like to have a positive coefficient, so we have a 2 here and a 1 here. So if I subtract x and subtract x, that's going to leave that coefficient positive. So on the right side, we're left with 35. And on the left side, we're left with x plus 46. So we can subtract 46 from both sides of the equal sign, and our 46 cancel, and we're left with x equals negative 11. And that is our solution.